A decision tree is something you can follow along, and it helps you figure out what to do next. Let's say, right, somebody gives you a sequence of numbers. Very first thing you want to ask, do the x values have a common difference? Let's look at this problem, this number 2 problem here. Do the x values have a common difference? What's the difference from here to here? 2. And the difference from here to here? 1. So those are the differences. And they're not the same. So what do you do if the answer is no? You try to add or delete values to make the x values have a common difference. So in this context, what does that mean? Can I add anything to make the x values have a common difference? Where they don't have one? What would I have to add here? A -2, right? And then I'd have to figure out what this is. Here I'd have to add what? A 1. Or I could just go from here to here. My value here is, my difference here is 2, right? And from here to here, my difference is 2. And actually, if I go from 2 to 4, my difference is 2. So if I take this one out, and I take this one out, or actually just leave those in, right? I just don't go from here to here. These are the ones that have a common difference of x. Okay. What's the difference from 1 to 5? 4. What's the difference from 7 to 11?
4.
What's the difference between 11 and 15?
4.
Okay. So what you're doing here is if the answer is no, then you add or delete some things to try to make the differences the same for all the x values. And then once you've done that, then you check to see, do all of the f of x values have a common difference? Okay. So over here, when we did that, we had a common difference over here, 2, 2, 2. Common difference over here was 4, 4, 4. If the answer to this is yes, then what you do is you take the common difference for the f of x values and you divide the common difference of f of x by the common difference of the x values, and whatever you get, let's call that d, the difference for the sequence. So you take the common difference of f of x, which is what?
4.
Okay. And you take the common difference of the x, which is what?
2.
And you divide them, and what do you get?
2.
2. And that's the common difference for this function table here. From here to here, right, for each one. And once you have that, you know you have an arithmetic sequence, which is also a linear function. And basically, you could describe this arithmetic sequence by saying, if you want to get any value at all from the function, you have to take the value that came before it and add the common difference. Right? And that's 1/2 of the recursive formula. The other half is you just have to give 1 point, starting point somewhere. Here's the next part. If you want the explicit formula, it looks like this. F of x, take any term you want. Doesn't matter which term you take. We'll just call it an. And then you add the common difference multiplied by x minus whatever the number of this term was. If you want the explicit formula, it's any term at all plus the difference, the common difference, times x minus the number term that it is. So what does that mean here? Pick any term you want. Let's take 4 and 15, okay? A4 is equal to 15, and our common difference is 2. Here's an equation. any term minus the common difference times x minus the number of the term that you picked. Pick another one if you want. Right? A sub negative 3 is equal to 1. This one here from the table, right here, f of x equals 1 minus 2 times x minus negative 3. These two equations are the same. But this right here means no matter what values you have, all you need is one value. If you know it's an arithmetic sequence, all you need is the common difference and one value, and you can write the equation. What question should you be asking me now, do you think? What are we going to do next? Well, I've sort of left this gaping hole over here, haven't I? I've told you what to do if there's a common difference. But what if there's not a common difference? Then what do you do? Well, the next thing you want to do is find out, do the f of x values have a common ratio? If the answer to that is yes, let's call that R. Common ratio is R. What does that mean? What's an example of that? There's an example. Is there a common ratio there?
Yeah.
What is it? Okay. So it's, here's 2, right? Times 2, times 2, times 2, times 2. The common ratio of 2. So our ratio here is 2. So what does that mean? Well, the way we would describe this, first of all, it's a geometric sequence, which means it's an exponential function. And it means half of the recursive formula is going to look like this. In order to get any term, you take the term that came before it and you multiply it by the ratio. That's what a geometric sequence is. You take a term, multiply it by r, you get the next term. So now what? If you want the explicit formula, you take any term and you multiply it by the ratio raised to the x minus n power. So here, pick any term you like.
5 and 96.
5 and 96. So a sub 5 is equal to 96. F of x is equal to 96 times the ratio raised to the x minus 5 power. This way, whatever term you have, you don't have to go back and try to find 1, you don't have to find 0, you don't have to find anything at all. If you have one of the terms and you know the ratio, you can write the explicit formula. And this is sort of the decision tree that we have created, starting with, well, okay, here's a sequence. What do I do first? Well, first check to see if the x values have a common difference. And if they don't, see if you can make them have one. Then, do the f of x values have a common difference? If they do, then it means you're going to have an arithmetic sequence. You find the common difference for the sequence by dividing the difference of the f of x by the value of the common difference for the x values. And then you use that number and any term to create your explicit formula. F of x is equal to one of the terms plus your common difference times x minus whatever the number of the term is that you picked. Okay. On the other hand, if you come back here and it says, do the f of x values have a common difference? And the answer is no. The next thing you want to check is, well, okay, do they have a common ratio? Is there something that when you multiply each of the terms, you get the next term? Is there something that you can do so that it looks like this? In order to get the next term, you take the term that came before it and multiply it by the ratio. If that answer is yes, then you have a geometric sequence, an exponential function, and this is part of your recursive formula, but in order to get your explicit formula, all you have to do is take any term, multiply it by r, which is your common ratio, raised to the x minus whatever number this was power. And that gives you your explicit formula here.